Hello.
Gokhan.
Gokhan. Still your turn.
You're the
Hello,
moderator, right?
Apologies for that. Yeah. The next panel is going to be a pretty interesting one as well. It's to be an L1 or an L2. That's the question. We have two great teams here, Monad and StarkWare. But then I'll just let you guys introduce yourself and the project, and then we can start from there.
Okay. Hi, everyone. Eunice, Giarta, co-founder and COO of Monad Labs. At Monad Labs, we're building the Monad blockchain. It's an EVM equivalent L1. It's new. We're working on several optimizations to target 10,000 transactions per second, single slot single slot finality and 1 second block times.
Hi, I'm Oren. I'm CEO of StarkWare. StarkWare actually, our base is in Stark, which is our protocol. It's a zero-knowledge proof protocol. And we started out with that, was 7.5 years ago. We built a bunch of stuff on top of that. Initially it was StarkX, which today would probably be called an app chain. It was like an app-specific rollup. We're probably the first ones who did that. We had a bunch of them. We still have a bunch of them in production. And then we've built StarkNet, which is a general purpose layer 2 on top of Ethereum. I guess we're going to talk mostly about this now.
Perfect. Yeah, thanks a lot. The first question is going to be basically, I think, what are some of the difficulties of building L1 versus L2, L2 versus L1? And if you were to start and make these design choices from zero at this moment, would you still go the path that you have taken, building an L2 or an L1? Would you like to start, Eunice?
Sure, yeah, I can start. Definitely key to hear Oren's take, especially since it seems like you guys have been able to do a little bit of both and through the various products. But yeah, from the very beginning, so Monad as a team started with 3 people in early 22. And from that moment, it had always been a vision to build a more performant version of the EVM client. And so the idea was always an L1. And the reasons behind that are strictly because there's a lot of optimizations that can be made at that base layer. Leading into the current cycle of L1s, well, I guess maybe like looking back at the previous cycle of L1s, a lot of them in the 2017-2018 era were pretty much like taking forks of existing clients. Geth is a big example, and making very surface level modifications to it to juice performance numbers. But fundamentally, nothing really did change. Maybe, actually consensus, I think, was the big piece that was interesting, given that at the time Ethereum was proof of work, and there was a lot of excitement around transitioning that into different proof of stake protocols. But the execution client was more or less left untouched. And a little bit of background about our team. My 2 co-founders, Keone and James, came from Jump Trading, so it's the high-frequency trading side of the arm before, for I think like 8 or 9 years before transitioning into Jump Crypto. And so having institutional knowledge about building very high-performant, low-latency systems where basically tick-to-trade times were 300 nanoseconds. So like, you know, orders of magnitudes faster than the fastest blockchain speeds that we see today. Like that's the performance that James and Keone were used to working with. And so, you know, taking that in mind, building a lot of the optimizations into the execution client to us made it an obvious decision to build an L1 around that level of performance. So, yeah.
So, I mean, the bottom line is, yes, I would probably do the same thing today and start with an L2. But I think that's not the first question I would like that we asked ourselves back then. So like I said before, we started with proofs. Now, we think proofs bring a very big benefit to blockchain in that they break this equation where if you want decentralization, you have lots of nodes, and each and every one of those nodes have to execute all the transactions of the network. Because that's basically what gives you the blockchain trilemma, right? Because if you want everybody to be able to run a node, you want the requirements to run a node to be small. That means you can't run too many transactions. That limits your throughput. Now proofs break this asymmetry because now you could have like somebody or a single entity or a small subset of the nodes actually run all the transactions and also generate a proof that all of this was valid. And then you can have a very large number of nodes verifying that, not by re-executing transactions, but just by verifying the proof, which is a lot less expensive. Now, you could build a layer one around that. Like, I mean, if Ethereum was built with zero-knowledge proofs as part of the protocol, it could have solved this trilemma by itself, and everything would be fine. But Ethereum was built without knowledge of this, so they didn't do it back then. But now, when this already exists, so you have Ethereum, you also have Bitcoin. Like, you have networks that are limited in terms of scalability and cost and a bunch of other things, but they are existing networks, and they have a very strong network effect that at best will take us a very long time to replicate if we want to do it ourselves. So if we say, okay, we'll build a layer one network that's better than Ethereum, we probably can technically, you probably can technically as well, but that's not enough. I mean, first, it needs to be a lot better, but then you'd have to rebuild a lot of the network effects that Ethereum has. It has lots of users, it has lots of people participating in it, it has lots of software, it's decentralized, very decentralized. At best, it's going to take us years to get there. So the idea of a layer two is, okay, Ethereum has that. Well, Bitcoin has that as well. If we knew how to do that on top of Bitcoin, maybe we would have started with that. But let's ride on the networks that do have this decentralization, censorship resistant, credible neutrality, all those nice things for that, for security, and give the throughput as a layer on top of that because we can. So that's the long explanation as to why I would still do the same today.
Interesting. Okay, thanks a lot. So maybe a related question, and this is something that you were alluding to, Oren. Basically being part of the Ethereum ecosystem as an L2 and tapping into the liquidity, the users, the branding of it. And on the Monad side as well, we have the EVM, right? Like you still get to tap into the developer ecosystem that Ethereum has cultivated. In that sense, I think there are 2 points to it. One is that the technical part, like how much of that liquidity user developers actually flow to your ecosystem because you're an L2 or you're EVM compatible L1. And I think there's a more softer part of it where the cultural flow, like how much of branding do you actually get out of Ethereum because you're an Ethereum L2, or maybe EVM compatibility, does it also bring that to you? So maybe the technical side and the cultural side of it, I would love to get your opinion on that. This time, would you like to start, Oren?
Okay. So I think there are a few factors here, like you say, and probably all of them are somewhat of a double-edged sword as well. Because, for instance, EVM is a big thing, right? So you're EVM compliant, we're not EVM compliant. That's both a disadvantage and an advantage. It's a disadvantage because, like, if you have people who have built stuff for EVM, they can easily deploy on you if you're EVM, and they can't if you're not. If you have developers who know how to develop in Solidity, then they already know that they don't have to learn a new language, which is a friction. On the other hand, even that is also a disadvantage because sometimes this translates to, okay, so now a lot of the people actually using you and building you are not really your community. They're Ethereum's community. And they don't really care about you. I mean, they've built something in EVM, they can deploy on all the EVM chains, but they don't have any sentiment to any of them specifically. So it's both. Being a layer 2 on top of Ethereum versus a separate layer 1 is similar. I mean, people in the Ethereum community are often more favorable to stuff that's built on top of Ethereum. So that helps if you're a layer 2. But technically, it doesn't do that much. Because if you're not EVM, it doesn't help you with the code. Liquidity still needs to move. It might be easier to move to an L2 than to another layer 1. I'm not sure it's a lot easier. So I'm saying if you're a layer 1 in EVM, you're still partially, in a way, part of the Ethereum ecosystem.
Yeah, from a technical perspective, I think there's a lot of synergies that could be had because of quite frankly, the resources available are probably the most repeatable things that are advantageous to all types of developers. So those that are coming fresh into the crypto space, for example, oftentimes Solidity is the smart contract language that is, I don't know, probably first on a Google search. I didn't check it per se, but I would imagine that it'd be one of the first ones that pops up. And there's, there's a lot of educational materials around that to act as like the gateway drug of sorts into crypto development. Beyond that, though, app devs should find the right chain for them, whether that is an L1, whether that's an L2, whether that's Ethereum or something else. Due to, there's cultural factors, sure, but then there's also the what performance and technicals are unlocked based on the specific blockchain that they're looking at. This might be like a bit of an unrefined analogy, but the Monad is in many ways like a rebuild, or not in many ways it is. It's a rebuild of the EVM. Like we're using the same specs that were designed, over a decade or around a decade ago at this point, and the implementation is different. So there's an element of like backward compatibility, but then there's also improvements that could be made available on Monad blockchain that aren't seen on Ethereum right now. The crude example that I was going to mention is like the Windows operating system and the way that it evolved over time, where for many new versions of Windows, apps were still able to be backward compatible. So like an app built for Windows 98, an app built for Windows 95 would still be valid on a Windows 98 machine. But maybe not necessarily the other way around, and I'm kind of seeing it that way. So while sure there is like some community built around like Windows 98 versus Windows 95, like they're not necessarily they're not 100% overlapping either, and so I don't know. Again, a bit of a crude example there.
All right.
By the way, the one thing maybe I've skipped is like why have we built a language which is not EVM compatible?
Right.
Because there's a trade-off there as well. The reason we didn't do it back then is because we tried to optimize for what would be most efficient for proving. So we tried to build the simplest general purpose language that will be focused at the most efficient proving. And EVM was optimized for something else. And we didn't want to carry the limitations of EVM as well. Now, the disadvantages are quite clear because you can't just take EVM code and run it. I just want to point some of the advantages. For instance, it does enable you to do a bunch of things that the EVM doesn't enable you to do. And even if it does, when you try and support backward compatibility, you often don't really reap the benefits. So for instance, I'll give an example. One of the things that work really well in StarkNet, for instance, we have account abstraction. So all accounts are smart contracts. So you could do stuff like two-factor authentication and Face ID and game sessions, et cetera, et cetera. It's very strong. Apps can build on top of that, very nice features. Now you could do account abstraction over EVM as well. But on Ethereum, most accounts are EOAs. They're not smart contracts. So now if you build an application for Ethereum, you can't really say, okay, I'll just build it for account abstraction because you're going to lose most of the users. So now if you have to support EOAs, all of a sudden you can't have all those nice features that you can once you have. So often that actually like weighs down on you if you actually want to support it backwards. So there are benefits and also disadvantages.
Right.
I actually want to commend the fact that creating a new language that is strictly beneficial to the users that are that it's designed for, I think that's the right thing. And I agree that in many ways Solidity as a smart contract has a lot of faults. There's a reason why some developers prefer Viper, or there's thoughts on okay, how do we make a Rust-based smart contract language that can actually compile down into EVM bytecode so that it could run on EVM? Hopefully in the future we can start thinking about much better user experiences for the developer, and that includes the selection of language or the creation of specific programming languages that are just much easier to build with.
One recent trend, I think, in the last couple of months that we're seeing on Ethereum L2 landscape is mostly, it used to be the case that a lot of people are asking, hey, when are you decentralizing your L2, etc. And now I think it's becoming clear that there are two camps where one of the L2 camp is basically just keep it centralized. Like that is the advantage of the whole L2 gameplay. We don't even have to build our consensus mechanism, and we can beef up the, the sequencers and basically process as many transactions as we can. On the other hand, maybe for more like for rollups like Aztec, where actually decentralizing and using a base rollup is actually by design, it should be that way because it concerns the privacy side of things. And then I think this is, Oren also mentioned that like if we do the L1, like this means doing a lot of things Ethereum has done before, and it's being part of the consensus system as well, right? And this is one of the inefficiencies of maybe building an L1. So I would love to get your comments on like this new trend of basically L2s just focusing on beefing up the sequencer and sort of managing, focusing on that part. And maybe building an L1 is where you still have that problem, but there are obviously different ways of solutions in the market as well, where we would see with Solana too. Yeah, would love to get your comments on that. Eunice, would you like to start this time?
Okay, sure, yeah. Yeah, I feel like a lot of the recent L2s have definitely followed that approach of like super beefy, single node, centralized processors of sorts. Sure, it works, but you do lose out on a lot of the benefits of blockchain as a principle. Like, and I alluded to this in like the quick presentation that I had earlier, but you lose out on decentralization by having a single sequencer. Like it's literally centralized, like there's one. And then secondly is the trustlessness aspect of it. Like you have to fully trust that sequencer. These are two core tenets of blockchain technology and crypto as a whole. So I think there's like a pretty big disadvantage from that perspective. Like, yeah, I mean, maybe it's more philosophical than anything else, but it is a disadvantage, and that's something that users should be mindful of. On the note of the L1 difficulties, actually, can you quickly remind me of the question again so I answer right?
Yeah, basically like building an L1 and building the consensus system for that L1 is one of the most difficult parts of it.
Right.
And then
yeah, so this is probably why like keeping decentralization is what makes scaling L1 so difficult, because like again, an easy, I shouldn't say easy, but like one way out is by reducing that, right? Like going all the way to the centralized sequencer. In lieu of that, though, you have to take into consideration, okay, what are sufficient bounds of decentralization? Like, how do you geographically distribute nodes and ensure that communication and latency from one node to all the way to the other side of the globe, returning back to the original node across like all of the participants in the network is done efficiently? Like, that's the hard part. Many consensus mechanisms have gotten to the point where it's quadratic in nature. So, every node talks to each other node, but that grows very quickly, and it's not super scalable to a point. So the challenge there is to find something that would actually scale appropriately. I'll talk a little bit about Mono BFT, but it's the consensus mechanism that the Mono blockchain is deploying, and it's linear in nature. So but it's a hard problem. There are ways to improve upon the consensus mechanism for an L1, but it's not easy. And so it's like, I mean, you could take an easier route and go the centralized manner, or try something a little bit more difficult. Sorry, maybe a little bit of a spicy take there.
So, first of all, in terms of first principles, definitely decentralization is complex. It's easier to do something centralized. Though, to a large part, that's the whole idea behind blockchain. I mean, if you're fine with a less centralized system, you don't need blockchain, right? Centralized systems work well, have worked well before Bitcoin and everything. So I think essentially we do have to, in most cases, we do have to have something central. No, it's not decentralized. It's permissionless. It's censorship resistant. It's all those good things that decentralization enables you to do. Now, having said that, there are a few different use cases that use blockchain today, and they don't all necessarily need the same thing. So I can see use cases that want to ride on top of blockchain as a technology, but could make concessions in terms of centralizations. But I think if you want like a general purpose network over which a bunch of different things are supposed to run, which is pretty much what public networks are trying to do, it probably has to be decentralized. So for layer ones, that's probably a must. For layer twos, we can make some concessions because in a way we are riding in some aspects on top of the decentralization of the layer one. But still, even if you want to do a general purpose layer two that a lot of people will deploy on and run different things, you want it to be censorship resistant, you want it to be credibly neutral, you want it to be permissionless decentralized, so you'll end up with the same, maybe slightly bigger area of solutions, but with the same problem.
Overall, also curious about, I think, the economic side of things. When build economics, the L1 versus the L2 side. And I think there was this token terminal published this thing where they were basically arguing that Base from day one is actually profitable. But if you look at actually all the other L1s in the space, like Bitcoin, so you want to actually reach to like mass adoption with majority of the applications in the world running on. The only way to an L2 based approach or app chain based approach, right? Would love to get your take on what is the path for Monad in a case where it gets the mass adoption. How do you scale this to, like, would you consider getting this modular approach adopted by Monad as well? How would you see that feature?
That's a great question. Yes, and I think ultimately there are going to be bounds of what technology can do in a decentralized network. Like there's strictly latencies that you can't bend science between communication from like one part of the world to the next. The same way that like speed of light is limited. You can't make speed of light any like light can't move faster than the speed itself, like that kind of thing. Unless there's some science that I don't know about. But the point being, like with what Monad Labs is trying to do with the Monad blockchain is push the boundaries of getting to that point of like actually utilizing the hardware to its best ability. And same with like pushing the software to actually meet where that hardware can be performant. So that's kind of like the take that we're going with. Like certainly maybe and hopefully there's a future where, we can maybe use off-chain ZK proofs to segregate the consensus and execution piece even more and, have execution run and be validated via ZK proofs that are then communicated back to the consensus blocks and whatnot and expand from there. But I think what we're seeing right now is like we haven't even gotten to the point where we've maximized the hardware and software in combination with each other. And so that's what we're working towards.
Okay, perfect. I got a couple of other questions, but I'm afraid we're out of time. Thanks a lot, Oren. Thanks a lot, Eunice, for your insights.
Thanks.
Thank you.
Thanks, Oren.